Hello everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to Mahar Siddhanand University, Rohtak. So, guys, I will discuss topic recursive procedure, and in recursive procedure, I told you 2 or 3 points already, right? So, today I will share two four more example related to principle of mathematical induction and the recursive formula and so on, right? So these questions will be your old question, is related to your old question papers, right? So let's see. And this lecture is the last lecture of your MFCS unit first and unit fourth, right? So doubt, if you have any doubt, then ask me, right? Okay, let's start. So recursively defined function. So 1 minute. Okay. So recursively defined function means specify the value of the function for the first term, right? That means you already have your initial value. Second step gives a rule for finding subsequent values using a previous values beginning at those defined in the basis step. That means the meaning of this line that you have your first value and you will use your first value to find the next value, right? So there is an example here. If f is defined recursively by initial condition is given f0 is equal to 2 and fn plus 1 is equal to 3 and fn minus 1. So we need to calculate f1, f2, f3, f4. So initial condition is given here, so you will find your f1. So for the f1 you will put n is equal to 0 in the given equation. Then f1 will be 3 into f0 minus 1, so 5. For the f2 you will put n is equal to 2, then your f2 is 14. For the f3 you will write n is equal to 2 in the recursion formula, so you will get 3 into 14 minus 1, 41. And for the f4 you will write n is equal to 3 here, so 41 into 3 minus 1, that means 122, right? So this is very easy, and this is your 2 marks question, always come in your exam, right? Now give a recursive definition for a to the power n type. So here you can see that your equation is a positive and negative condition, but here there is a sequence of a square, a cube, and so on type, right? So your initial condition is a to the power 0 is equal to 1. We know that a to the power 1, a square, you can write a into a. So one by one step you will get your sequence and you will get your final values, right? So this is your multiplication sequence. Now note that recursive definition are well defined, meaning that the value of the function is defined for every positive integer. We are able to use a form of mathematical induction to prove recursive procedure, right? So I told you mathematical induction already, so we are just understandable to the topic recursive procedure, right? So there is an question here, and this question is came in your 2018 exam, I think, old previous paper. So let's see. Solve the recurrence relation subject to the initial condition an is equal to 5, an minus 1 minus 6, an minus 2 for n is greater or equal to 2. So with a naught is equal to 7, a1 is equal to 15, right? So an is your given recursive formula. So for the solution, I told you that you will consider a solution an is equal to x to the power n type. So before the solution, you need to find the order of the recurrence relation. So what is the order of the recurrence relation? Order of the recurrence relation is the largest term order and the smallest one order, difference between the largest one and smallest one. So largest one order is n here, smallest one is n minus 2. So find the difference between both of them. So n minus n plus 2, n cancelled out, so 2 is your final order. So you will get n is equal to 2, order is your n. 2. So an is equal to x to the power n, you are considering a solution. So here put x to the power n, here at 5 into x to the power n minus 1, minus 6 into x to the power n minus 4. So just put the value of n here, and you will get x square minus 5x plus 6 is equal to 0. So this is your quadratic equation. So I told you for the solution of the quadratic equation you will get two roots. So 6 is divided by 2 into 3, 2 plus 3 5, and so x minus 2 is equal to 0 and x minus 3 is equal to 0. So we have x is equal to 2 and x is equal to 3, two roots, right? So roots are real and distinct. So there are two cases there. First one, roots are real and distinct. Second case was roots are real and the same. So our roots are different. So we will apply for first case, roots are real and distinct. So an is equal to a into 2 to the power n plus b into 3 to the power n, right? Now we need to calculate the value of a and b, because with constant our solution is not the required solution, will not be required solution. So calculate the value of a and b. So for the calculation of a and b, our initial condition already given in the question. So given condition is a naught is equal to 7, a1 is equal to 15, right? So put n is equal to 1 in equation 1. So where a naught is equal to a into 2 to the power 0 plus b into 3 to the power 0. So what we have, 7 is equal to a plus b. This is your second equation. Now again put n is equal to 1 in equation 1. And then 2a plus 3b is equal to 15, right? Now solve equation second and third. So a plus b is equal to 7, 2a plus 3b is equal to 15. So just equal a part of constant. So twice a plus twice b is equal to 14. That we are multiplying by 2 in equation second, right? So a plus b is equal to 7, then you will get 2a plus 2b is equal to 14. So 2a cancelled out. Now we have b is equal to 1. So we have b is equal to 1, then you can calculate a is equal to 6, right? Now put the value of a and b in equation 1. So that equation will be your required solution. So we have a n is equal to 6 into 2 to the power n plus 3 to the power n, right? Now there is a question related to mathematical induction. So prove using mathematical induction for all that for all n is greater or equal to 1. So 1 plus 4 plus 7 plus and so on, 3n minus 2 is equal to n 3n minus 1 by 2. So let it be proved by mathematical induction. So for the mathematical induction, Pn is given 1 plus 4 plus 7 plus and so on, 3n minus 2, right? So put n is equal to 1, because in mathematical procedure we calculate first for n is equal to 1. So P1 is equal to 1. So 1 in left hand side we are getting, and right hand side just write n is equal to 1. Then also in right hand side we are getting 1. So P1 is true, right? Now for put n is equal to k, then what we will have, pk is equal to 1 plus 4 plus 7 and so on, 3k minus 2, right? So in the right hand side we can see that this is also true. So Pn is true for n is equal to k. Now third one condition is, check is it true for n is equal to k plus 1. If it is true for n is equal to k plus 1, then we can say that our theorem hypothesis is true for all n, right? So pk plus 1 is equal to 1 plus 4 plus 7 plus 3k minus 2 plus 3k plus 1 minus 2. So why we are writing 3k minus 2? Because this term 3k minus 2, after that we will write 3k plus 1, right? So after k you will write k plus 1. Then just to solve this, 1 plus 4 plus 7 plus 3k minus 2 plus 3k plus 3 minus 2, right? So we can write this line as we have this line value is pk, right? So pk value is, we have pk value k 3k minus 1 by 2. So k 3k minus 1 by 2 upon 2 plus 3k plus 1. Just solve this line and you will get pk plus 1. Just solve this line and we have 3k square plus 5k plus 2 upon 2. So we can see here that this quadratic equation is not in the form of this one. We need to convert all the form into this one, n and 3 n minus 1 by 2. So just convert it into our given form. So we can write here 3k, k plus 1 plus 2, k plus 1, k plus 1, 3k plus 2 upon 2. So we can see that this part n and 3n minus 1 are same. So we can say that pk plus 1 is true for n is equal to k plus 1. Hence, by principle of mathematical induction, pk plus 1 is true, right? So pn is true for all n. Now, this question is related to your first unit. Determine the value of coefficient of correlation, and all the value are given here. So we need to calculate coefficient of correlation. So you can use that formula to calculate coefficient of correlation. So we have all our values here, and this is your 8 marks question. All the calculation is given here. Just you will put the value in your formula, then calculate 2 or 3 more steps, then you will get your final answer, right? So this question also came in your exam. Now there is another question, and this question is related to again principle of mathematical induction. So 1 plus 2 plus 3 plus and so on, n is less than 1 by 8, 2n plus 1 whole square. So first, for n is equal to 1, so p1 is equal to 1. We can see here 1 is less than 9 by 8, right? 9 by 8 is your greater than value, greater than 1 value. So p1 is true for n is equal to 1. Now pk for n is equal to k, so pk is equal to 1 plus 2 plus and so on, k less than 1 by 8, 2k plus 1 whole square. Now we need to calculate for n is equal to k plus 1. So pk plus 1, we have 1 plus 2 plus 3 plus k here, k, then after you will write k plus 1. So pk plus 1 is equal to this one. Now this value is pk plus 2k plus 1. So you can write it 1 by 8, 2k plus 1 whole square plus k plus 1 is less than. Now just open it and solve this. Then you will get is less than 4k square plus 12 plus 9. Then you can solve this and write it 2k plus 3 whole square. 2k plus 3 you can write 2k plus 2 plus 1 whole square. Then 2 is common, k plus 1 whole square, right? There is 1 here. So we can see that this also is in the form of pk. So it is true for pk plus 1. Now hence pn is true for all n, right? Guys, there is a formula of mode here, so you just learn this formula, because I think remember that I did not share this formula with you, so I'm sharing this. Mode is equal to L plus f1 minus f0 upon 2f1 minus f0 minus f2 into h. So L is your lower limit, h is your size of interval, f1 is your frequency of model class, f0 is frequency of the preceding class, and f2 is your frequency of the succeeding class, right? So this formula is we will better understand by the example. In a class of 30 students, marks obtained by students in mathematics out of 50 is tabulated as below. Calculate the mode of data given. So marks is given 10 to 20 marks students are 5, 20 to 30 are 12 students, 30 to 40, 8 students, 40 to 55 students, right? So number of students, always I told you frequency. So this is your frequency and this is your marks. So what we will do, we will just see maximum class frequency is 12. So first we need to find the maximum class frequency here. So maximum class frequency is 12, and 12 is coming in the interval 20 to 30. So 20 is your lower bound and 30 is your upper bound, right? So frequency class interval corresponding to maximum frequency is 20 to 30. Thus the model class is your 20 to 30, right? Now we have L is equal to 20, because lower bound is our 20 in the class interval 20 to 30. And f1 is your 12, h is equal to 10, h means class interval difference. So 10 to 20, 20 to 30, we can see that there is a difference of 10 here. And f naught is equal to 5. So just check if your f1 is 20. So your f1, your sorry, here your f1 is 12. So f naught will be 5 and f2 is equal to 8, right? Proceeding and succeeding. So just write the value of here all these points here, and you will get your answer. And next, what is more definition? The maximum number of frequency value is called mode. So there is another example here. Find the mode of data 3252356653525. So what number is repeating most of the maximum number of times, right? So here highest frequency is 5, that is repeating again. Number 5 is repeating 5 times, so mode will be 5, right? Okay. So I think I have already shared each and everything with you, and I'm not okay. I think nothing is left here. So yeah, guys, you just prepare all of your topic, unit 1 and unit 2, and have any doubt, then ask me. All of you are free to ask, right? Thank you.